Our lecture today is about a hypergeometric distribution. What is the hypergeometric distribution? It is a discrete probability distribution. It is similar to the binomial distribution. It is the similar of binomial distribution, but the difference between binomial and hypergeometric, in the hypergeometric distribution, the trial is without replacement, but in binomial, it is with replacement. This is the main difference between the binomial and hypergeometric. The binomial, it is a very good approximation of the hypergeometric distribution. Then we can solve the problem of hypergeometric distribution by using the binomial distribution formula in the condition of the number of sampling, the sampling which is in small must be less than 10% of the sample space or the population. In this case, we can use the binomial distribution to solve the problem of the hypergeometric distribution as an approximation. The hypergeometric distribution is without replacement of not independent trials. The formula for hypergeometric distribution, if we have x is a random variable, this random variable has the hypergeometric distribution. Then, to find the probability of random variable x, we have to use this formula, which is P probability for random variable x equal x. This equal x combination k a time multiply by n minus x combination of n capital minus k. All of these over n capital combination of n small. X small here, it is the number of successes items in the chosen sample. If we choose a sample of n small, then x small is the number of successes in the n small, the chosen sample. K is the number of successes in the population in n capital. Then k is the number of successes in the population or in the total sample space. N small minus x is the number of failures items in the chosen sample. Then n minus x, n small minus x small, is the number of failures item in the chosen sample. N capital minus k is the number of failures items in the population. Then we have a success in the chosen sample, we have failure in the chosen sample, we have the chosen sample which is in small, and we have the population which is in capital. We'll take this example for hypergeometric. If we have 6 engineers and 19 programmers attend an international conference, these the total of these people is 25 names. These names put in a small box to choose 5 names randomly. These chosen will be without replacement. Then, because it's without replacement is the key here, is without replacement, then we have to use the hypergeometric. Then what is the probability that 3 engineers are picked? Then 3 engineers is the successes here. 3 engineers is the successes. Then the failure will be the programmers. We choose here 5 persons. 3 of them are engineers. Then the other 2 will be the programmers. Then the solution, as we said, the key here is without replacement. Therefore, we have to use the hypergeometric distribution. Number of trials are not independent because it without replacement. The sample of 5 names is equally likely. Therefore, it is a hypergeometric distribution, and we have to use the formula of hypergeometric distribution. Then probability of x random variable equal x small, the successes, equal x combination k time multiply by n minus x combination n capital ناقص minus x, all of these over n capital combination n small. As we said, n capital is the population, which is 25 people. N small, the chosen sample, we will pick 5 names, then the chosen sample n small equal 5. X is the successes. The successes here is the engineers. Then x small will be 3. K, the number of successes in the population, the number of successes in capital, which is 6 engineers. In capital minus k, it is the failure in the population. Failure in the population, which are the programmers, which is 19 people. N small minus x is the failure in the chosen sample, which is 2, because we picked 5 people, 3 of them engineers, then the rest, which is 2, is the programmers. Then 3 combination 6 multiplied by 2 combination 19 all over 25 combination 5. We solve the combination as we take before, which is 6 factorial over 3 factorial over 6 minus 3 factorial. Then the probability will be 0.0644. We see here 3 plus 2 equal 5, 6 plus 19 equal 25. Then we will take 5 from 25. The expected value and variance for hypergeometric, the expected value equal n small multiplied by k, the successes, over n capital, then n the chosen sample multiplied by the successes in the